just out of curiosity, I'll test the power. 12.22 volts, that's good. So we'll plug that in there. Where's it go? In there. Switch it on. Right, now this is interesting. When I switch this on, my camera goes haywire. So I'm going to switch this back on and I'm going to see if my recording camera goes faulty. Yes, it does. That is flashing around. Am I still recording? I'm still recording, but I've gone off. So I'll switch that back off, deactivate my camera and activate it again, and now I'm back. So this could be really cheap, or this could be faulty. I suspect this is really cheap. If I use this power supply which came with the system, it works on the TV, but I cannot capture the video through an HDMI capture card. I've tried this one, which is just a cheap one, and I've tried this one, the Ava Media Live Gamer Mini, and it just refuses to work. So I have another 12 volt power supply here. I'm going to try this one. Right, there we go. So I know this does work, and I'm going to try the old power supply again. Take that one out, put this one back in, switch it on. Right, I've switched it on at the wall, deactivate, and it doesn't activate again. So I will switch it off, which you're not supposed to do. I will plug this replacement one in, and we'll see if we can get that back up. There we go. So it's definitely, there's something wrong with this power supply. I don't know what it is, but it doesn't let us capture onto the computer. So I don't like using this. So what I'm going to do is I'm going to crack this open, and I'm going to see if there's anything missed out. Perhaps they've missed something out, like a coil, an inductor, or whatever. I'm not happy using this. Let's see if we can crack this open, find out how cheaply it's made. I don't recommend people opening power supplies. So what have I got on the top? I've only got one diode. I've got a capacitor. I'm going to cut these. I'm not going to use this power supply, so I'm going to cut these off. Is it going to be... It's going to have voltage in there. So this is what's been causing the problems. Some kind of interference, I believe. So as you can see, there's very little in the way of components on this board. There are 2 electrolytic capacitors, a small ceramic capacitor here, 1 diode, and a transformer. And on the other side of the board we have a couple of SMD components, what I would assume is the power management chip and the bridge rectifier. Now one thing I noticed was the line from AC goes through this zigzag trace on the board. That's meant to work as a fuse directly to the bridge rectifier. And if I bring up a video by Hasib Electronics, this is a great video. He explains why the fuse keeps blowing when you've got a short circuit on your input. You can see here he has a fuse, a class X capacitor, a varistor and an inductor. He goes on to explain what they do and how they protect the circuit. I recommend anyone with an interest in SMPS supplies to watch this. He explains it far better than what I could. So there's a class X capacitor first, a varistor and an inductor, a coil. Not forgetting a proper fuse. You can't fit all of these components in something small like this. So how do they do it on a better power supply? Now I have a Netgear branded power supply, and this puts out 12 volts and 1.5 amps. So I'm going to crack this open and I'm going to compare a branded one with a non-branded one, because I'm interested to see why these don't cause problems but why this one does. I suspect it's because this is missing, but we'll see. So let's just see if I can get this open. I might warm it up. Now, it goes without saying, I don't recommend you do this. This is not an educational video. Don't go open power supplies that aren't meant to be opened. Oh, you never, there's a screw in. There's a tiny screw in there, which wouldn't have made much of a difference because I haven't got a screwdriver that'll fit in there. You can already see this thing is rammed with components. Right, look at the difference. Wow. So this one, ooh, I've just took a hit. I did try this to make sure that it worked earlier. It's obviously still got some juice left in it, because I've just took a little shock there. This is why I tell you, don't do what I do. Finger's gone numb. So look at the difference. 12 volt, 1.5 amp, 12 volt, 1 amp. So you've got all these components. You've got the fuse, you've got the varistor there, you've got a class X capacitor in there, and you've got a small coil. I can't see where the bridge rectifier is. Under there. The AC comes in here. The line comes in this way, I think, through the fuse here. And then you've got those parallel components. There's the inductor, the other side of the inductor. Can't see where the bridge rectifier is under there, but I'm not going to chip away at that. I recently bought a replacement power supply for my Spectrum 48K, and I was wondering, I bought it from, let's see, where did I buy it from? That's where I bought it from. Bought it from Amazon, from a company called MyVolts, a 9-volt power supply. I was wondering if it was worth it, buying a branded power supply. And looking at the difference between these two, it's definitely worth spending a bit of money and getting something a bit more reliable. I've put this back together, and this now isn't giving us any output. I didn't record it. This now is not giving us any output. So I think I've either damaged something when I've pulled it out, or something's gone short circuit when I give myself an electric shock. But the fuse still works. The live is connected up, and the neutral is connected up there. The cable is okay, so that's working, but I've got no output. The capacitor had 320 volts in when I opened it up, so all of the input seems to be working, but for some reason it's not outputting anything anymore because I've broke it. Let's have a look under the microscope. Right, what have I done? I think I can see what I've done. When I've pulled it out of the case, I've damaged resistor R7. That's what I've done. That is just clumsy, and I've damaged that capacitor C15 there. I've knocked that off. So what's that? 823 R7 823. That capacitor is probably savable, but I don't know what 823 is. As you can see, my 823 resistors have arrived, and thankfully they're the right size. So we're going to take this one off, and I'll reflow this C15 capacitor. Hopefully I haven't damaged anything else, and I can get this power supply working again. Right, let's see how we go on. I'll put a bit of flux on, knock these off. Push that back into place. Hang on. We'll do some left-handed soldering. There we go. Close enough. Right, look how small these are. The hardest part's not the soldering, it's getting them out the packet without having them fling all over the shop. Trying to grip it. If I can do it without trying to grip it. Look at that, perfect. I'm getting good at this. It's been a while, but I'm getting good at it. And a bit of left-handed soldering again. There we go. I'll clean it up first and then we'll check for continuity. That's lovely. So that looks like it connects to the resistor. And it does. And then it comes down to here. Yes. C15 this side. Does it go to there? Yes, it does. Perfect. Okie dokie. So if I've managed to fix this, it's only cost us £2.59 and I got a pack of 100 from Switch Elec on eBay. I'm hoping they come in handy at some point. So I want to put this back together. Where's the top? That goes this way. This will be great if it works because I've managed to fix it and I've only given myself one electric shock. I'll get my load lamp just in case. Here we are. Right, we'll plug that in there. We'll plug the load lamp on at the wall and we'll switch on. Nothing's blew up yet. And we'll check this for 12 volts. And I've got nothing. I'm still not outputting anything. That's a shame. No, nothing. Still broken. Right. I'm wondering if I can plug something into this to make sure this is working. So I'll plug this in and I'll see if my phone charging rapidly. So this is working okay. So there's still something wrong. Still something wrong with this. I can genuinely say from experience, if I open this, it's dangerous because I got a blooming shock the last time. So don't do this at home. I'm definitely worried about taking that out now. And rightly so. Let's check the voltage on that main cap. Yeah, the high side seems to be working okay. So there's something else wrong with this. I wonder if I've damaged something else around here. Put the metal prongs down. If I've put my pliers across this resistor, I might have shorted this chip, I suppose. I think that cap might be damaged. So I'm going to take that off and test it with a multimeter out of circuit. If it is damaged, I might have some trouble finding out what it is. Although there's some information on the board there. I might be able to find out what it is. But we'll take it off. We'll give it a measure. I wonder if there's part of it under here. Doesn't seem to be. Kind of looks okay. I think that's the glue. That looks alright as it goes. That looks okay to me. We'll clean that up. That looks fine. I'll just pop that back on and we'll give it another shot. If not, I'll have to try and find out what this is. I'll measure it with the multimeter before I put it on. 0.33 nanofarads. So it's not shorted or open. Right, I'm going to plug that back in, but I'm going to leave it out. Obviously not recommended at all. Now this is off at the moment. I'm going to switch it on at the wall, but I'm going to look away just in case something pops. Right, switch on at the wall. And still nothing. That cap has 330 volts in it. This is negative. I've got anything down here? Now, I've got 12 volts on a cap down here. So this is interesting because I've got 12 volts here. If I use that as negative, I've definitely just had 12 volts on one of these. There. 12 volts. Ah, now look, I do have 12 volts output. So is there a problem with this? I can't believe this wire's damaged, but it looks that way. I'm not getting any voltage out of the cable, but it is outputting 12 volts. So it's technically half fixed. It's just got a damaged cable. How have I damaged the cable? Oh, I'm a complete idiot. What have I done? Look what I've done. I've got two cables here. I've got to be careful because this is still on, but I've got both cables from the power supplies that I've been working on. This is off the cheap Chinese one I'm trying to get a voltage out of, and this is the actual one connected to the blooming power supply that I'm working on. Right, 12 volts, so I have fixed it. I'm a complete idiot. I don't know how I managed to do it, but I have fixed it. Right, switch that off, let that capacitor drain down, put it back together. What else is there to do? Wrap the video up, I suppose. I've glued this one back together because that's working fine. This is the cheap Chinese one. I've had a thought. I'm wondering, perhaps someone can offer any extra info. Is it causing a problem through the AC mains going back into the AC, or is it sending interference out through the DC? What I should have done, in hindsight, I should have hooked this up to my oscilloscope and looked at the DC output of it. So I've learned it's probably a good idea spending a bit more money and buying a decent branded power supply rather than the cheapest, search the results by lowest price. Don't do that on power supplies. Buy something decent that's got over voltage protection and over current protection and things like that. This book arrived today, Troubleshooting Solid State Electronic Power Supplies by Ben Gaddis. I'm looking forward to having a read of that, learn a bit more about these, and I'm hoping one day I can take one of these apart without electrocuting myself. So that's it. That's it for today's video. Thanks for watching. I hope you've enjoyed it, and don't try this at home, but I do hope to see you in the next one. So thanks for watching.